Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Rabbit on the Staircase. It's an it's a medium problem. It's of discrete math type, and I'll let you guys go over it once first. So the question is kind of confusing, as in you might not understand what exactly is asked of us. Basically, we need to find a function, say f of n, for variables from n is equal to 1, 2, 3, and all, and so on. Basically, for whole numbers. So, yeah, so we need to find a function f of n, which is defined for whole numbers, where f of, let's say, a value x, so x is one of those integers. So, f of x is equal to all the different possible ways to climb x stairs. So let me just write that out once. So yeah, there you go. So for example, f of 2 would be all the different ways that the rabbit could have climbed two stairs. So basically that would look like, well, let's just think about the different combinations. Well, it starts on floor number 0, right? And it could go to 1 and then 2, or it could go directly to 2. So there's two ways. So f of 2 becomes 2. So let me take another example, say f of 3. So for f of 3, you could imagine going from 0 to 1 to 2 to 3, or you could go from 0 to 1 to 3, or you could go from 0 to 2 and then to 3. So as you can see, there's three possible ways. So f of 3 becomes 3. So now we over here calculated f of x for x being specific values, but we need to define a proper function, kind of express the function f of n in a more general manner. So to find the general pattern or sequence f of n follows, I would hint you guys towards thinking about something related to recursion. So basically try to think of a recurrence relation between consecutive values of n. What do I mean by consecutive values? Say n and n minus 1, n minus 2, n minus 3, so on and so forth. So try to think how each consecutive value might be connected to some of the values before it, right? And try to form a recurrence relation using the observations you might find. So if you look carefully, you might start to realize that the value f of n is somewhat related to f of n minus 1 and f of n minus 2. Now, how did I come to that conclusion? Well, the number of the total number of different possible ways to climb n stairs can be related to the total number of different ways to climb n minus 1 stairs and n minus 2 stairs. And that is because, let's say I calculate the value of f of n minus 1 and f of n minus 2, right? Now, what does f of n minus 1 denote? The different combinations of climbing up to n minus 1 stairs. Now, for all of those combinations that are included in f of n minus 1, if I just add a plus 1 to the end of all of those combinations, so let's say it went from 0 to 1 to 2 to 3, and then I just add, and so let's say I'm just assuming n to be 4 over here. So n minus 1 becomes 3, and n minus 2 becomes 2. This is just an example. So if I calculate all the different ways to reach floor level 3, and then do all of those different combinations, I just say that, okay, once you do all these steps, you just add 1 to it. You will reach f of n, right? You'll reach level 4. And the same thinking goes for the case of f of n minus 2. So if we calculate all the different ways to reach the second floor, all I could do is say, okay, you add 2 to all of those different combinations. So let's say one combination that is included in f of n minus 2 is 0, 1, 2. And now I could say that, okay, for f of n, where n is 4, you could just add a plus 2 to the end of it. So that would look like 0, 1, 2, 4. So basically, I'm trying to find all the different ways that I could reach n minus 1, all the different ways I could reach n minus 2. And once you reach n minus 1, you can directly reach f of n using a plus 1. So that doesn't create any new combinations. It just uses all the pre-existing combinations and modifies all of them. And the same goes for n minus 2. So basically, to reach level 4, I'm reaching level 2, I'm reaching level 3, and I say that, okay, there's a perfect mapping of all the combinations included over here. that will also reach us to level 4. There's a perfect mapping of all the different ways I can reach level 2 and straight away jump to level 4. And if I just add those values, then I would get the value of f of 4. I would actually get all the different possible ways that I could use, all the different combinations that the rabbit could perform in order to reach level 4. Now, one doubt that some of you guys might get, that since I'm including all the ways of reaching level 2 and then jumping to 4, and all the ways of reaching level 3 and then jumping to 4, am I by mistake gonna include the cases where I reach level 2 and then I go one jump to level 3 and then I go all the way to level 4? Well, those are already included in f of 3. Now, why are you including them in f of 2 also? Well, it's important to understand over here that we are not doing that, because whenever we reach level 2, we are assuming that we are only going to do plus 2 every time. So we're never going to reach level 3 from all the different ways that we calculate f of 2. Since for all of those combinations that f of 2 is going to denote, for example, 0, 1, 2, 0, 2, so basically these two combinations, I'm going to just do a comma 4. So these are going to be the values for f of 4. And for f of 3, it could have been something like this. And now, since I need to include all these values, all I'm going to do is do a comma 4 at the end of them. And this becomes f of 4. And so this is one component of f of 4. This is the other component of f of 4. And these two combined include each and every case, or each and every possible way of reaching f of 4. So basically, the recurrence relation becomes f of n is equal to f of n minus 1 plus f of n minus 2. And we also notice that f of 0, or basically the number of possible ways of reaching the 0th floor, which we're already standing on, is 1. And the number of possible ways of reaching the first floor is also 1. Now, this might look familiar to you guys. This is basically the definition for the Fibonacci sequence. And this Fibonacci sequence is exactly how f of n is acting like. So basically, to answer the initial question, which was asked, that what kind of sequence is depicted by this function, the answer is the Fibonacci sequence, or basically this mathematical definition over here. I hope you guys understood the solution, and thanks for watching.